Hello there, today I'm going to show one interesting charge choice task, and my version of the solution. It is if x plus y plus z equals x by z and all them variables are positive, strictly positive, then what is the minimum of this function? Okay, let's try to solve it. The first idea is to get x through yz from this equation and substitute it here. We can get it in 2 seconds. Then just note that they two are positive. It's positive means this thing is positive. It will be very important sometime later. So it was for every two variables because you may write it as x, z, and y. That's why it was everywhere. Okay, let's go next. I some sort of rewrote it because seriously it is a huge function. But let it be at the end. Then we will move unit there. The numerator to get rid of this 2yz, the numerator of the denominator, just like this. But note that it is 1 plus z square times 1 plus y square, right? And this is the whole square of yz minus 1. We will just move it upside the numerator and go next. Just like this. But do you remember this thing about this function, right? Do you not remember? Wait a second. And now it is strictly positive. It means its absolute value is itself. Just like this. And of course I wrote it. Just check it out yourself. It's trivial. Now let's do one interesting thing. For every free z, we are going to find such y as it is extremum point, which is d over dy differentiation by y-axis is 0. It will have all the positive extremum and minimum extremum, but we'll just check them all. I'll say that there's only one point, which is of course minimum, yes, and we just will solve this, find y for every z. But seriously, differentiation, this thing is very trivial. We just move this thing, we just multiply this 0 and d or dy of this thing to square of the square plus 1 to make it more easily for charge relation, and then just like see that if it is equal 0, then this thing derivative times this thing equals this thing derivative times this thing, just like that written. And so let's do the next. Then we just move this thing upside, open it because it's strictly positive, and get something like this. We will get rid of this zy squared, move y there, and square both sides to get rid of the square. Just like I said, but wait. Here we got something non-symmetric. It means we can go ahead and differentiate by dz axis and get the same thing by the changed variables, which is such as this. We can sum them both. If they both are right, then we can sum them. It will be still right, and we get something interesting. Then we may just cancel this thing if it is not 0, but it is not 0 because y and z are both positive. The thing cannot be 0 because seriously they both are bigger than 0, right? It cannot be workable. That's why we just cancel them both and get 3 equals yz. But we will not get yz, we will get xz, we will get xy, and it's the same thing. 3 equals yz equals xy equals xz, just like that. Now we just look there. For example, cancel y there and get z equals x. Same thing there. I cancel x because they cannot be 0 and get y equals z. Seriously, y equals z, x equals y equals z, and they all are equal to square root of 3, positive square, because they all are positive. Now coming back, we know this interesting thing that they all are the same and equal square root of 3. It means their square is 3 and the square root of 4 equals 2. 3 times 1 over 2 is 3 over 2. And this is the answer. It's minimum area. And this is the answer.